Welcome. This example says we have the number of calories in a random sample of 18 Chester's churros, and we're going to construct a grouped frequency distribution of the data, starting with an initial class boundary of 269.5. I've taken care of that, and the class width is 10, so the distance to the next class would be 10. So let me just indicate here that that's what I did there. To get to the beginning of the next class, we add the width. And then just to make this one a little bit quicker, I've gone ahead and filled in the boundaries. So let's write the limits. So the limits will be whole numbers because the data are whole numbers. So the whole numbers inside the boundaries. So after 269.5, the next whole number would be 270. And then we'll just do dash. And then right before you get to 279.5 on a number line, the last whole number you hit would be 279. All right, and then you can just keep adding that class width. Again, that was 10. And then we can just quickly fill up all of these class limits for each class. So I'm just going to go down the page, adding 10. And for the upper limits of each class, same thing, we can just keep adding 10. So basically, I made this example just easy to work with. So we can just quickly show you another histogram in a moment, but let's do some counting of frequencies. So churros between 270 and 279 calories. I'm just going to circle. So there's 2 of them. And then 280 to 289. We'll have 4. And then 290 to 299, this is going to be our biggest set of churros. There's going to be 6. And then 300 to 309 is going to drop back down to 4. And then 310 to 315, I'm sorry, 310 to 319, there will be 2 of them in that range. All right, so we have our frequencies of 2, 4, 6, 4, 2. And then I'm going to just use my sigma notation. So if I add those frequencies together, we should get 18 churros. So you can check there and we will get 18. So there's your frequency distribution. And then we will create the frequency histogram of that data. All right, so again, to speed things along a little bit, I went ahead and put the boundaries on the axis. I'm just going to label my axis here. So we're talking calories in a churro from Chester, Chester's churros, calories. And then the frequency in this case would represent the number of churros in each of these classes. So our first class, we had 2. The second, we had 4. The third, we had 6. And then the fourth class went back down to 4. And then our last class, we had 2. All right. So on this distribution, I'm seeing there's just one peak here in the center of the graph. So when I have just one peak in a graph, it's called a unimodal distribution. So uni for one, so one modal position. And rather than being skewed, this graph is perfectly symmetric. Generally, when we talk about shape, it doesn't have to be perfect, but this one actually is. So we had 6 in the middle, and then to the left and the right are mirror images of each other. So that's how we get that symmetric shape. And as well, when we have that one peak in the center, and then it basically tapers off evenly to the left and the right of that peak, we start to discuss something called a bell shape distribution because it resembles a bell. So at the bottom here, then, as well as being symmetric, the shape also appears to be bell shape. bell-shaped. Okay, and I will be returning to my Chester's churros example throughout the semester.